So we're being asked to factor by grouping using the area model. And it's by grouping because I see that I have 4 terms in my polynomial. So we're going to do the grouping method because that's the only method that allows us to do 4 terms. The very first thing you always need to check is you need to check to make sure this is actually in standard form. Remember, standard form meant that the highest exponent was written first. My highest exponent is 3. And then the exponents go down in descending order. So 3, 2, 1, no variable, exponent was a 0. So it is in standard form. After that, we need to find the GCF. Finding the GCF should always be the first thing you do because it might make these individual monomials, these individual terms, easier to work with, smaller. So first we need to see if we can find a GCF. Remember back when, that's how we would do the prime factorization. So I'm going to prime factorize all 4 of these terms. So 4 terms, 4 lists. The prime factorization of 8r to the third is 2 times 2 times 2, because 2 times 2 is 4, 4 times 2 is 8. R to the third meant there were 3 of them, so r times r times r. The only way to get a negative is if you have a negative 1. No other number is allowed to be negative. The 1 is the only number allowed to be negative. Prime factorizing 64. I know that is 8 times 8, but 8's not prime. This is 8. So here is my 8, and then I need another 8. So those 3 were in 8. Here are 3 more that are for my 8, so that is 64. If you type this all into your calculator, you'll get negative 64. R squared meant it was r times r. R is just an r. Negative 8, the only way to get a negative 8 is if I had a negative 1, and I know that 8 is 2 times 2 times 2. So to find my GCF, I'm looking for one letter variable or one number that all 4 lists have in common. If I am unable to find anything, that meant my GCF was a 1, and I am not able to find anything because these all have 2's, this does not have a 2. These 3 lists all have r's, but this list does not have an r. So my GCF is 1, which means this is the smallest that the problem can currently go. Our next step is to put it into an area model. Now we're trying to undo the multiplication, which means right now we have the inside of the area model and we want to find the outside of it. The first term always comes in here. The last term goes in here, and we're just going to go in order. So 1, 1, 2, 2, 3, 3, 4, 4. So the order it is, you're just going to read them in order. So now that I have my area model figured out, we only need to find one more GCF. So looking across this row right here, the number 8 and the number negative 64. What do 8 and negative 64 have in common as their greatest common factor? I know the biggest number that can divide both of these is an 8. Now looking at their variables, there are 3 r's here and 2 r's here. So I know that they share the largest amount of r's is 2. So this right here is 8r squared. This is the only one you need to figure out. After this, you are going to find the others using what you know about area models and multiplication. So if this is 8r squared, whatever number goes right here had to multiply to the 8r squared to get an ar to the third. So this must be r, because 8r squared times r is 8r to the third. If this is r, a number needs to go here, so this number times r gives me r. The only thing that times r to get r would be 1. If this is a 1, some number up here times 1 needs to give me negative 8. So this must be a negative 8. If I have all 4 sides, go around and double check, knowing your skills with area model. 8r squared times r is 8r to the third. 8r squared times a negative 8 is negative 64r squared. R times 1 is r. 1 times negative 8 is negative 8. So my sides are all accurate. So my last and final answer, or my last and final step, is to you give me my final answer. And how we do write that, you are supposed to write the GCF. So if my GCF, I found my GCF over here, I'm supposed to write my GCF first. And then this side is 1 parenthesis, so 8r squared plus 1. This side is the other parenthesis, r minus 8. Now, if the GCF is 1, we tend to not write it. So this answer would be 8r squared plus 1 and an r minus 8. And if you need help seeing it, this parenthesis came because that is what this side says. This parenthesis came because that's what this side says. And so this right here is our final answer. You factored it and we're done. So we're going to continue by factoring by grouping using the area model. And then we have our 4 terms, which is by grouping. Step number 1 is standard form. I got to make sure first it's in standard form. If it was in standard form, my highest exponent should be written first. 3 is not my highest exponent, 4 is. So this should be the first term. So I'm going to rewrite it with positive 12p to the 4th as being the first term. After 4 comes 3, so that's a negative 21p to the 3rd. So 4, 3, here's my 2, so positive 28p squared. And my 1, because that was a negative 49p. So 4, 3, 2, 1. I am currently in standard form. Now I need to find the GCF. There are 4 terms, so I should be finding 4 lists to find my GCF. So 12 is 2 times 2 times 3, and p to the 4th meant I had 4 of them. The only way to get a negative 21 is if I had a negative 1. 21 must be 3 and 7, and p to the 3rd meant there were 3 of them. 28 is 4 times 7, but 4 is not prime, so 2 times 2 times 7. P squared was 2 p's of them right there. The only way to get negative 49 is to have a negative 1. 49 is 7 times 7, and then there was a p. So we are looking for our GCF. So looking through, it has to be in all 4 of my lists. There's a 2 here, but there's not a 2 here, so that doesn't count. 3, 3, no 3, so 3 doesn't work. There are 7s in these lists here, but there is not a 7 up here, so it doesn't work. These 2 lists do have negative 1s, but the others don't, so it doesn't work. So I don't see a single number that all 4 lists share. But I do see that all 4 lists have 1p. So my GCF is going to be a p. So I'm going to come over here and I am going to write my GCF of a p so that we keep these in order. My GCF is p. Now I need to go back through and I need to figure out what was left behind in my lists when I took the p GCF out. So if there are 4 lists, there better be 4 chunks of information left behind. So 2 times 2 is 4. 4 times 3 is 12. So I have 12p to the 3rd. So 12p to the 3rd is my first term, my first list, my first chunk. Chunk 2, term 2. Negative 1 times 3 times 7 is a negative 21. P squared. 2 times 2 times 7 is 28 times that p, so it's a positive 28p. Negative 1 times 7 is a negative 49, and that was it. 4 lists, 4 chunk leftovers. There has to be the same number. So now that I found my GCF, step number 3 is to do the area model. And we're going to do the area model to what was left behind, the rest of the problem. So here is my area model. You start with the very front and you walk your way through. So negative 21p squared, 28p, negative 49. And the very next step is just to find one GCF. So I like to do the first row. So 12 and negative 21. 12 and negative 21, the highest number they have in common is 3. If this is p to the 3rd and this is p squared, the highest number of p's they have in common is p squared. I found this one GCF. So the rest of it is just to find the others using multiplication. So if he's 3p squared, 3 times something needs to give me the 12. It must be 3 times 4. P squared times something needs to give me the p to the 3rd, so there must be another p. 3p to the 2nd times 4p. 3 times 4 was 12. P to the 2nd times p is p to the 3rd. So now coming over here. 3 times a number has to give me negative 21. Must be negative 7. because 3 times negative 7 is a negative 21. P squared, if I don't put anything here, I still get p squared. So he's done. One more left. Negative 7 times somebody has to give me this negative 49. Must be a positive 7, because positive 7 times negative 7 is a negative 49. Now just go back through and make sure that you actually did it all right. So 3 times 4 is 12. P squared times p is p to the third. 3 times negative 7 is a negative 21. And then you have your p squared. 7 times negative 7 is a negative 49. 7 times 4 is 28. P times no more p's is just a p. So this is correct. So my last and final step is for you to give me my final answers in terms of parentheses. I have to label my GCF first. Do not forget your GCF. And then inside my parentheses is the sides. So this side is going to give me my first parenthesis. So I have 3p squared plus 7. And then this side is going to give me my other parenthesis. So I have 4p minus 7. So if you want to see your final answer without all the colors, p, 3p squared plus 7, 4p minus 7. And this is our final answer, and we're done. So we're being asked to factor by grouping using the area model. The very first thing you need to do is you always need to make sure you're in standard form first, which meant the highest exponent need to have been written first. My highest exponent is a 3, so he should have been the first term. And that is a positive 24x to the third, so I'm going to write a positive 24x to the third. If he's 3, my exponents are now supposed to go down in descending order. So now I'm going to look for 2, so here's 2, so a positive 4x squared. 3, 2, here's my 1, so minus 60x because it was a negative 60. 3, 2, 1, now I'm looking for the none. Here is my none, and that's minus 10. So I'm currently in standard form, which means the next thing I need to do is I need to see if there's any way to make these numbers or these terms smaller. Try seeing if I can factor out a GCF. So because there were 4 terms, there should be 4 lists that I am comparing. So since there are 4 terms, there need to be 4 lists. So we're going to go ahead and prime factorize these. 24 would have been 8 times 3, but 8's not prime, so I had to break 8 up into its prime numbers. So there is 8, so there's my 8 times my 3. X to the third meant there were 3 x's. 4x squared, prime factorizing, would have been 2 times 2 times x times x. The only way to get a negative is if you have a negative 1. No other number is legally allowed to be negative. The prime factorization of 60 is 2 times 2 times 3 times 5, and then we need the x. Prime factorization of negative 10 is a negative 1 times 2 times 5, because the only number allowed to be negative is 1. So now I need to look for my GCFs. So I'm looking for a single letter or a single number that all 4 lists have in common. I see that all of my lists share a 2, and they share no variables. So my GCF is going to be a 2. And so I'm going to come over here and I'm going to say, hey, look, they had a 2 in common. And so my GCF comes out here first. And then what's left behind is what was left behind in the other lists. So 2 times 2 times 3 times x times x times x. So I have 12x to the third left over in the first list. Multiplying, I have a positive 2x squared left over in the second list. The third list is a negative 30x, and the last list is a negative 5. 4 lists meant I had 4 terms, 4 chunks, 4 groups left behind. Step number 3 is to do the area model. So I'm going to do the area model to what is now left behind. So here is my area model. The first guy always goes here, and then we're going to walk through, and we're going to just kind of walk through the area model. And now you just need to find the area model's 1 GCF. I like to do the first row. It's usually easier for me. You can do any one you actually want. So 12 and 2. The number 12 and 2 have in common is a 2. If this is x third and that's x squared, the most number of x's they have in common is 2, so it's x squared. The minute I find 1, the next step is to find everybody else by multiplication. So 2 times 6 will give me the x, 2 times 6 will give me the 12. X squared times x will give me the x to the third. 2 times 1 will give me the 2. X squared times 1 will give me the x squared. 6x squared times a negative 5 will give me a negative 30. Negative 5 times 1 does give me a negative 5. So I went ahead and I double checked everybody. My last step is to get the final answer. Your final answer always starts with the GCF you notice at the very, very beginning. And then I'm going to end up having two parentheses. What goes in the parentheses comes from the sides. So this side is going to go into this parenthesis, and this side is going to go into this parenthesis. This is 2x squared minus 5. So here's a 2x squared minus 5. This is a 6x plus 1. So here's my 6x plus 1. And this is my final answer, and I'm done.